In example 1 here, we're going to graph this wonderful polar equation. R is equal to 2.5. And to graph polar equations, to get a very basic understanding of what these points are, is they're just simply points that are solutions to this equation, same thing that a rectangular would be. So one thing you can do is make yourself a table, and we could go r and theta instead of x and y. So what I like to do is I like to use the theta column first. So we'll go with theta being 0, and we'll do this in degrees, so we'll go 0 degrees. And what we need to do then is we need to figure out what would happen for this one right here for the radius. And this says r is 2.5, so you would still be at 2.5. There's no theta here, so theta doesn't matter. If we did this for, let's say, 30 degrees, r is 2.5, that would be the same thing. You could go on to like 90 degrees, r would still be 2.5, and so on and so forth. If we make each one of these 1, each one of these rings here 1, then to graph 0, 2.5 comma 0 degrees, that would be right here. That polar point would be right on the polar axis rather. 2.530 would just be 30 degrees here, and then out 2.5. 2.590 would be here. And you can tell that at every single other one of these angles, no matter where we're at, we're going to have all these points. And these are just representative solutions. Even if you had an angle somewhere in the middle, so let's say you had an angle here of 15 degrees, the radius would still be 2.5. So all these points are lining up. If we plotted every single point that would work, we would get something that looks just like this. So this happens to be a circle with radius 2.5. In contrast to what you would see in the rectangular coordinate world, is you would see x squared plus y squared equals 2.5 squared. That's what the equation of this would be. But in polar, it's simply r is equal to 2.5.